So now that you know a little bit about what a condition variable is, which of course is the underlying concept upon which Java condition objects are based, let's talk about another aspect of this. And we're going to talk about something called the guarded suspension pattern. And the guarded suspension pattern is what's typically used when you are going to implement programs that use condition variables. And we'll talk about this in more detail. So when you use condition variables in practice, they're almost always used in conjunction with a pattern called the guarded suspension pattern. And you can read about this pattern at the link below. It's also described in my Pattern-Oriented Software Architecture Volume 4 book, which is the pattern language for distributed object computing. And in either case, the way the guarded suspension pattern works is it requires both a lock to be successfully acquired and a precondition to be satisfied before an operation can actually execute. So that's what the guarded suspension part means. And this pattern is applied to operations in multi-threaded programs that can only run when a particular condition is satisfied. So again, the conditions that we have to satisfy is first we have to be able to acquire the lock, and keep in mind that you could have multiple threads contending for the same lock, so that might be locked when you go to try to get it. And if it's locked, you just have to wait for the lock to be available. A condition variable is always, always, always associated with a lock. Very, very important thing to remember. And then the second thing that has to happen in order to make progress, to make forward progress, is a precondition must hold. So while the condition is not satisfied, you can't make forward progress. And this, of course, calls into mind the famous phrase by Gandalf when he's warding off the Balrog on the bridge at Khazad Dûm, which is, "You shall not pass." And if you're familiar with the book, he says something slightly different, but the basic idea is you can't make forward progress. Now, Gandalf is very militant in not letting the Balrog pass. For the condition variables we're going to talk about and the use of guarded suspension, let's assume that you can eventually make progress. Maybe you're a nice Balrog. So what happens in this case is some thread T1 will use a condition variable to suspend its execution until some other thread, Tn, notifies T1 that shared state it's waiting for on may now be satisfied. And the key is may. Very, very important. And one of the consequences of may is the fundamental non-determinism in concurrent programs. So the way that this works is, more at the implementation level, you have to acquire a lock. And then with that lock held, you check some condition that will most likely involve shared mutable state. And because of the tentative nature of may now be satisfied, you typically have to run this thing in a loop. So you run it in a loop so that if the condition is not satisfied, you go to sleep waiting to be notified that the condition may be satisfied, in which case you wake up again, the lock is automatically reacquired, and then you check the condition again to see if it's satisfied. And so this process is basically a little idiomatic way in which the guarded suspension pattern works. The conditions that are being checked here can be arbitrarily complicated. So they might involve, say, several fields or method calls or network calls or whatever. They're basically things that just have to be satisfied in order for you to make progress. So again, it can be a bunch of different things, but the key point usually is that these conditions involve state that's shared between multiple threads. So going back to the example of trying to wait to take an item from a bounded queue, like an array blocking queue or a link blocking queue, when the queue is empty, you want to suspend yourself and wait for the queue to be not empty. And that involves shared state because, of course, the queue will be shared between producer and consumer threads. And so there's shared state that has to be checked, and it has to be locked appropriately by the lock to ensure mutually exclusive access. So the key point to remember here is that any state that's shared between multiple threads that are using a condition variable must absolutely be protected by the lock that's associated with the condition variable. So the calling thread, whoever's trying to get through the guarded suspension gatekeeper mechanism, if you will block, potentially repeatedly block, while the condition is not satisfied, and it'll have to wait. And the way it waits is it calls the await method on the condition. And the condition will then do two things atomically. It will release the lock and put the calling thread to sleep until it gets notified. Now, how does it get notified? Well, some other thread, Tn, will come along and do something that changes the state to a point where T1, the thread that's waiting, might want to wake up and try to make forward progress. So it's kind of like the example with the human known use of the pizza delivery protocol, where after somebody has put a pizza on the counter or returned the keys, they ring a bell to notify the sleeping pizza delivery people that it may be time to wake up and check to see if they can get a pizza and the keys. So the way that this works at the implementation level is there's some method on a condition called signal. And there's different names, there's notify and signal and so on. But basically what happens is you're signaling some waiting thread or waiting threads that they should wake up and then try to make forward progress. So when they're awakened, when they're signaled, that causes await to return, and it will automatically and atomically acquire the lock. So once the lock has been reacquired, then we loop back around again and recheck to see if the condition is now to our liking. If it is to our liking, then we're going to make forward progress and get through the guard. If it's not to our liking, we go back to waiting again. Now, the thing to remember is that waiting on a condition variable atomically releases the lock and suspends the thread, puts the thread to sleep. Those two things are atomic operations. And likewise, when it wakes up again, before it returns from await, it also atomically reacquires the lock. And while it's waiting in await, it will be suspended, meaning that the thread will be put to sleep and will not make any forward progress until it's been notified or signaled that the condition may now be to its liking. So when the condition is signaled by thread Tn, it will cause the thread that's blocked to wake up, and it will automatically reacquire the lock. That's all done by the condition variable implementation itself. After the lock is reacquired, then you can go back and check the condition, and this will happen over and over again until we finally get the condition to be satisfied, at which point we can then go ahead and do the operation processing that's protected by the guarded suspension pattern. So that's the end of the overview of guarded suspension. It's very important to understand this pattern in order to make sense of how you program with condition variables in general and condition objects in particular in Java. Be aware that there are other technologies that use condition variables. For example, C and C++ both support condition variables. In C, you can use something called POSIX condition variables. And in C++, they have something similar, just with a C++ wrapper around it. Though the abstractions are very, very similar, some minor differences in syntax and some minor differences in use cases and idioms for the patterns of applying those mechanisms, but they're all very similar to what we see with Java.